the naming of some alkenes. People are super duper interested in it. Notice that I did put some video content up on Friday. I've got some examples of naming alkanes. I'm going to try later today to get finished a video on isomers, constitutional isomers. So for alkenes, a lot of it is exactly like we did for the alkanes, with just a couple of tweaks. Remember, we're trying to name these alkenes. So step one is still looking for the longest chain, but it's the longest chain that contains both of the carbons in the carbon-to-carbon double bond, because that describes the core chemistry of the molecule, by including that double bond. So on those rare occasions, if you can't find a longer continuous chain that doesn't have both of the carbons, that's not going to be your parent chain. Parent chain is the longest chain with the carbons in the double bond, both of them. So we'll name the molecule, its core name, based on that longest chain. And as we did before, we want to number the chain from one end to the other. But instead of taking the number one carbon from the position of the lowest branch, because it's an alkene molecule, and this alkene double bond is paramount to the chemistry, we're going to number the main chain so that the double bond has the lowest possible numbering. So although from the alkane chemistry this would be carbon number one, because it would give us one fluoro substitution, it makes a 1, 2, 3, 4, a much higher numbered start for the carbon and the carbon-to-carbon double bond. The number from this end, the double bond starts on carbon number 2 rather than carbon number 4. So that's the end that we're going to number the main chain. So based on hexane, because it contains 6 carbons, it becomes a hexene molecule. But we also want to know specifically about the position that carbon double bond starts. It starts on carbon number 2. So into the core of the name, we'll just add that information. Between the core and the suffix, ene, we'll just squat into the name the fact that it's on carbon number 2, dash 2 dash. So hex 2e. Now that we've locked in that main chain and we have double bond position, now we can think about our branches. Because we locked in the double bond from the left hand side of the molecule, that branch is actually on carbon number 6, so 6 fluoro hex 2e. Now, in some of the textbooks, so this alkene here, I'm going to name this alkene. So, first thing we see and notice should be that there's this alkene double bond in the molecule. So the name ending is going to be ene. We then look for the longest chain that contains both of the carbons in the double bond. Functionality, the reactivity of the molecule is tied in to that carbon-to-carbon double bond. So that's crucial. So the longest chain with both the carbons in the double bond, longest chain is 10 carbons long. So the longest chain is 10 carbons long. Do we start here or do we start here in the molecule? With the alkanes, if that double bond wasn't there, we stand at this end because it gives the lowest possible numbering to the branches. And with that double bond, 1, 2, 3, 4 from this end. So we're going to start the chain numbering from this end because it gives the lowest possible numbering the first carbon in the double bond. Because a name only makes mention of the first carbon of the two, so if it starts in carbon 4, it has to finish in carbon 5. So we wouldn't bother talking about 4,5 alkene, it's just 4 alkene. Common sense tells us we can get away with that kind of minimal information. So there's our main chain number, carbons 1 through 10. And that also gives us a couple of branches on the molecule. Branch on carbon 8 and a branch on carbon 5. There's a bond linking the branch to the core parent chain. Remember, this carbon is part of the main chain, it is not part of the branch. So our branch starts here, 1, 2, 3 carbons long, based on propane, so the YL ending, propyl for a branch, and then just a bromine, take off the INE ending, put on an O for bromo. We'll list them in alphabetical order. So 8B bromo before 5P propyl. Again, the position of the double bond squeezed in to the parent chain. Deck 4E. First one. There's that double bond. So that's going to be carbon 1, carbon 2. Looking at an alkene. The longest chain, 1, 2, 3, 4. Or 1, 2, 3, 4, 5. So this vertical route almost is a longer version. 5 carbons in the main chain based on pentane. So it's pentene. Pent 1 ene. Want to know where that double bond is. So pent 1 ene. And then we have an offshoot from that double bond in the second carbon, 2 carbons long for that offshoot. So it's an ethyl branching molecule. Two ethyl, pent 1 ene. This is what our death pen should have. Second one. Again, double bond, ding ding. This is going to be an alkene. Longest chain, 1, 2, 3, 4, 5, 6 this time, based on hexane. It's going to be hexene. Ah, that's much better. Double bond starting in carbon number 1. And we have a branch of the molecule. 1 carbon in that branch. It starts on 1, 2, 3. The third carbon. So it's a 3 methyl hexylene. Of course, name it doesn't have to be written in capitals. It's just that my handwriting was rubbish. How we do it? Do we need that couple of minutes for the third and fourth? No? We do okay? So for the third one, again that double bond, the zinger tells us it's an alkene. Numbering is going to be easier from the right hand side this time. So carbon 1, 2, 3. And it's 1, 2, 3, 4, 5, 6, 7, 8 carbons long in total. So based on octane, it's an octene molecule, oct3ene. And we've got our branch in the molecule again, a chlorine atom, which is on carbon number 7. So it's a 7 chloro-oct3ene. Chloro-oct3ene. And the last one of the bunch is really slightly more tricky one. Remember from our alkane discussions, if the chain was longer than the cycle, then the chain would describe the core of the molecule, the parent chain. But we've got a functional group. So all bets are off in this case. We must stick with the functional group. So this bond is the most important part of the molecule. So this cyclohexene ring is more important than the octylcyclohexene chain. So it's a cyclohexene molecule. And we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons in the branch. That's an octyl branch of the molecule. There's the divide between the main molecule and the branch. That's the first carbon in the branch. That carbon is part of the main part of the main molecule. So either this is carbon 1 or this is carbon 1. The decision comes from which way round the molecule, including those two carbons first. Which way round would give us the lowest number to the branch. So starting from here, that makes this a branch in carbon number 4. If we started from this end, it would make it number 5. So this is a starting point 1, 2, 3, 4 around that molecule. So that's cyclohexene. No need this time to include the carbon double bond position in the core name. You could if you wanted, you could describe it as cyclohex 1ene, but because it's the ring and this double bond has to be the most important part, we're naturally going to make that carbon number 1. And just in terms of the branch, depending on where we start here or here, so that's carbon 1 as we go clockwise. An octyl branch, 4 octyl. Cyclohexene. If we can get away